Hi and welcome to this demo which is about Open Network Linux. So in this demo we got one of these open networking switches which is the Edgecore AS5712. It's a 48 port 10 gigabit per second switch, and we got two laptops here that we will be connecting to port number 1 and port number 2 of this switch. And within this demo we will load Open Network Linux on this switch, and we will also load the OpenNSL, Broadcom OpenNSL drivers on the switch, and we will configure the switch to allow the communication between the two ports which we have here. Now, since the machines we got here is just the two laptops, one laptop is here, is connected with this orange cable, is connected to port number 1 of this switch, as you can see here. So we got one of these SFPs, SFP plus 1 gigabit per second, which converts the 10 gigabit per second port into a 1 gigabit per second, and we can connect it to the standard laptop, standard machine with the copper connection. So this switch has, as you can see, it has 48 ports, and here I got one 10 gigabit per second fiber SFP, and it has 6 40 gigabit per second as well QSFPs here. We got two more ports here. With one of them here is the standard console, the RS232 or the serial port console, which I have connected through the USB to serial converter, and is connected to our test machine here. And we will also use the management interface. This is the dedicated out-of-band management interface of the switch, which we will be using it for uploading the ONL inside the switch. So I will connect this brown color cable here, and I will use this cable for doing the communication. So we got this laptop. This laptop will be used for our main test, and this is the small diagram we got here. So we got 10.001, which is the laptop here. We got on this side, as you can see, the IP configuration. That 10.001 is configured on this ThinkPad laptop. And we got the other one, which is 10.003, which will be this machine once we finish the configuration, once we finish loading the Open Network Linux on the switch itself. So what we are going to do is, in this demo, we will download the Open Network Linux. After downloading the Open Network Linux, we will install the Open Network Linux on this switch, which is the AS5712. We will boot up the switch, assign the management IPs, and we have to copy the OpenNSL on the switch itself. So this OpenNSL is a piece of software which is given by the manufacturer. So it's a Broadcom software, but it has been provided by the OEM vendor. So in this case, the Edgecore has provided this OpenNSL software to me. And once that is done, we load the OpenNSL. We will launch the OpenNSL, and we will do the basic configuration to create a basic layer 2 configuration between the two ports in this switch. So that's what we are going to achieve. I can power up this switch. I will turn off most of the fans of this switch just to make sure it doesn't make that much noise, but still it will be a little bit noisy. So in the beginning, this is during the startup of the switch, and let's connect towards, we will connect to the console of the switch to see what exactly is going on and what is required to load the Open Network Linux on this switch. And for those of you who are considering why this yellow cable is, so in the beginning, once we start loading the Open Network on the switch, I will use this brown cable, which is connected to the out-of-band management of the switch. We will use this cable on this laptop to load the Open Network Linux. And once that is done, we will disconnect this cable, and we will connect the yellow cable to this laptop. So you will not be able to see at that time when I'm doing this piece of work. And this yellow cable is connected to port number 2 on this switch. So the laptop, the two laptops, the ThinkPad and this box, the other laptop, they are connected to the two ports of the switch. And in this demo, we load the Open Network Linux, OpenNSL, and we allow the communication between these two ports. Alright, so as you've seen, the physical setup, now we are looking at our drawing again. So we got a management PC, which is this machine which you see here. We will use this machine to provision this the bare metal switch and loading the Open Network Linux on it. So the management PC, it has it got the DHCP server, which uses the DNS mask, and it got the FTP server as well, which I'm using a very lightweight Python-based FTP server on this machine. And we are connected through the console, the USB to serial connector connected to the serial port of the switch, and also we have that LAN cable connected directly to the management port of the Ethernet switch, the bare metal switch. So that's that brown cable which I was showing you earlier. This machine got a static IP on this interface, the 192.168.3.1, and we will use this interface for loading the Open Network Linux. Now, to start with, we will go to the Open Network website. We download the Open Network Linux from there, and we will start the installation on the bare metal switch after that. So let's go to the Open Network Linux website, which is opennetlinux.org. From here, we can just jump into the download, the binaries download here. Once you come to the binaries download, there are lots of options here, which I choose the latest version, which is 2018 6.19. And here also again we got some other different installers. So as you see here, the main difference is we got ARM64, we got AMD 64s, and we got PowerPC. And we got also Debian 9 and Debian 8. These are the differences, the architecture of the CPUs of the bare metal switches. So they are different. So some of the bare metal switches, they come with a CPU board based on an Intel processor, or they may come based on, you know, some kind of PowerPC processor or just the ARM processor. So you have different option of the processor. So the Open Network Linux has been compiled for different type of different type of CPUs, and based on the architecture of the processor and the CPU board, you need to install, you need to download the correct version. So in our case, the switch which I got here is that Edgecore AS5712, and I know it is using an Intel based processor. So I used the Debian version 8, which we got here, and I used the installed installer. The other ones, the SWI installer, they are used for generating the SWI, the base core image, which we don't need to do that here. So I just click here and I start downloading this the Debian 8 AMD 64 installed installer file. So let's give it some time. This is around I think it should be around half a gigabyte something. Let it get some time to get it downloaded. All right, so now we can see the download is over. Let's see where this file has been copied. It's copied in my downloads. Okay, so what we need to do is we need to go to the download folder, which is this one, Open ONL master. I'm copying this file to, we got a folder here which is for the FTP users, and I copy this file here. Now you see I have another file also in my FTP directory here, which is OpenNSL Acton 350. It's a Debian package. This file is the binary drivers of the Broadcom chipset within the switch. So I got this file from the Edgecore. So this file is supplied by the manufacturer of the switch, and which is compatible with this version of the Open Network Linux. So once we install the Open Network Linux, I will also install this Debian package, which enables the CPU board of the white box switch, of the bare metal switch, in order to be able to communicate with the Broadcom chipset inside the switch. So there is a PCI Express connection between the CPU board and the switch silicon, which this file, the drivers inside this file allows that communication. Okay, so we got this file here now. Let's git terminal. Let's go to the FTP folder. So it's home FTP user, and here is our file name. Let me copy this file, and I just create my installation script. So once the switch starts, we will use this command to load the to tell the switch that we need you to go and do the FTP to this machine, which is exactly the same machine. I have an FTP server running on port 2121, and just download this particular file which we just downloaded. So now in order to do this, I need to go and turn on the switch. It may be a little bit noisy, and once we turn on the switch, we just need to make a console connection to the switch, where we will use the well-known PuTTY command to connect to the console. So for connecting to the PuTTY, using the PuTTY to connect to the switch, we use the PuTTY. We call the USB, the TTY USB 0, and we call it with the baud rate 115200, 8 bits, N1, and no hardware flow control for this command. We paste it here, and now let me power on the switch, and after that we should be able to see the output here. It will be a little bit noisy also. Okay, so now we got the switch powered on. This is the initial BIOS of the output of the switch. Now we got a small little grub menu. So by default it goes to ONI to install the operating system. So ONI is the Open Network Install Environment, where it loads a small kernel, Linux kernel, which brings up the switch. It brings up the management interface. It gives the environment for installation of the operating system on the switch. Now as you can see here, the switch here, it brings up the Ethernet 0, which is that management interface with this. I tried the DHCP on this management interface, and it got the IP address also from the DHCP server where we are running on this machine. So 192.163.119 is the IP address of the switch. So by default it tries to do a TFTP, trying to look into the folder based on the MAC address of the switch, try to get the ONI installer by default, which is not there. We don't have any TFTP server running. So what I'm going to do is I'm going to tell the switch that, hey, this is the install URL that we have to go. So FTP to our server on port 2121, and download this file and install it. So let me copy this file, this command. Now here I have the ONI command, and let me see why I cannot paste here. Okay, install URL is FTP //68 211.113 column 2121 slash. You can do a very quick change here that lets me rename this file. Instead of this big file, just I call it ONL. Yep. So this makes it much easier. ONL. Okay. Connecting to the server, fetching ONL. So it looks like, let's see, is it really downloading or not? This is our FTP server, which is running on port number 2121. Oh, I put the wrong IP address here. Actually, I'm sorry. So the correct IP is 192.168.3.119. one. Okay, here we go. So it just downloaded the file, 186 megabytes, and this is the installer script of the ONI, which has, you know, the installation script. You know, it creates different partitions on the switch, and you know, whatever we are talking about here is all about the CPU module of the bare metal of a white box switch, the Edgecore switch, which we got. Nothing is happening right now on the ASIC of the switch silicon. So everything is happening on that small little embedded PC. Different partitions are being created. You know, the image file is being copied. You know, on the switch. The file is the partitions are getting formatted, and it builds also a grub installer. You know, at the end. Let's give it some time for this to get completed. Okay, as you can see, the installation is complete. Now the switch is doing a restart. Okay, so now the switch is booting up with ONL. Here you could see that, you know, the MA1 net dev has been installed, is enabled. So MA1 is the management interface. That same out-of-band management interface of the switch is the same interface which we use for loading the switch operating system, the ONL operating system inside the switch. Okay, and we got the login prompt for Open Network Linux. Let's use the root and ONL. Okay. Looks like the fans are screaming. Okay, so now if I do a uname -a, you can see it's a Linux kernel 4.14. Open Network Linux is running in this machine. Open Network Linux, it has, so the interface is just root Linux. It's Debian Linux, and it got some commands also, like ONL, ONLPD, ONLP dump. So ONLP dump, it provides a full dump of the switch. Let's say if I run this command, it gives all the details about the switch information. So these are the information which ONL has read from different chipsets inside the switch. So that the CPU board, it has an I2C connection to the board, and these are the information which the ONL is able to read. So for example, manufacturer is Acton, you know, the product, this is a AS5712 54 port switch. running on this, the ONI version and the other stuff. So for example, the next one is the power supply. So power supply 1, it doesn't have any model information. It is present as there, but it's not connected to the power, so that's why it's not showing any details. Power supply 2 is powered on. It has a model number. It has the all the details of the power supply. And then we got the information like the thermal information of the power supply, the LEDs. These are all the LEDs, because the LEDs are also driven by different chipsets and different the thermals, and also the fans. So here you can see that all the fans are present here, and also the RPM for each fan. So Open Network Linux, it manages all of this stuff, all the fair defaults accessories of the switch, within the switch, and also the SFP information. So as you remember, we had two SFPs connected to the port number 1 and 2. So port number 1, it got SFP inside, so Open Network Linux is able to read the EPROM information of the SFP. So the information from the SFP plus is here, and the other ports are all empty. And if you remember, I had one small little 10 gigabit per second fiber multi-mode SFP also on port number 46, which is showing here, and there we go. All right, so now the next thing for us to do is we have to set up the management interface. So let's do a if config. So as you can see, we got only one management MA1 interface on this switch. So MA1 is the management interface, that out-of-band management interface, which is now presented to Open Network Linux. So this is the same interface which in the previous step, it got the IP address from the DHCP server on this machine, and we were managed to upload the ONL software inside that. So now this is the same interface. It doesn't have any IP address, nothing. Now we have to configure this interface with the IP address, because we need to copy that files. We need to copy the files, the OpenNSL files inside this box. So let's go ahead and add the IP address. So I'm assigning 192.168.3.10 on this device. Again, I have to MA1 MyNet 192.168.3.10/24. We'll do a if config, and okay, the IP address is there. Let me try to ping machine 192.168.3.1. Yep, so we have established the connectivity. All right, that's fine. And the next step is we will copy the file, that file which I was showing you. Let me go back to our terminal here. We got the OpenNSL Acton, this Debian, this deb file. So this is the driver, the OpenNSL driver, which I'm planning to copy on the switch, and I have to install it in order to enable the communication between OpenNSL, between the Open Network Linux and the OpenNSL, the chipset driver. So OpenNSL is just the SDK library from Broadcom, which enables communication with the ASIC of the switch silicon itself. So from here, I should be able to, let's see if we can SSH to the switch itself. 192.168 is 3.10. Yeah, it looks like it is running. Let me try to do, and the password was ONL. Yeah, so this is the switch itself. So all right, so now let's copy the OpenNSL installer file to the switch. We can do it with the scp command. So scp OpenNSL to root at 192.168.3.10 /root. The password is ONL. Okay, the file looks like it's copied already. We have SSH access also to the switch now, but we can use still the console. Okay, so here we go. The file is here. Now we need to install this package on the switch. We use the dpkg -install OpenSL. So it looks like the package has been installed. To check that, if I do ls mode, I should be able to see new kernel modules, which I don't see them now here. I need to run an extra command to enable the OpenNSL. Yep, I need to run the OpenNSL setup, and there we go. So now we got two new, actually three kernel modules. The Broadcom KNet user BDE kernel BDE. These are the modules which has been installed by this Debian package inside our inside the switch. And these are the drivers, the kernel modules which are communicating to the drivers in order to reach to the switch. Now, in next step, we should be able to start running the OpenNSL, some of the examples of OpenNSLs, in order to start communicating with the switch silicon. Alright, so now let's start running the OpenNSL. So there is a folder called /user, and if I'm not mistaken, it's bin OpenNSL -acton examples. So we go in this folder. Here we got some few examples here. So by the way, let's have a look at the OpenSL Acton. So here we have only the examples folder. The other files like the binaries and the drivers, they are all installed in different locations. Now here I will run the example L2 firewall because it creates a layer 2 switch. It programs the ASIC to become like a layer 2 switch, and also it allows us to create some kind of firewall between the ports. So I use this example. So I'm going to run the example. Let me do it clear before that, so because it generates lots of outputs, it's better we see. Example L2 firewall. Okay. So here the example starts, it loads the driver. As you can see, PCI unit 0, the chipset is BCM 56854. So this is a Broadcom Trident 2 chipset inside this switch, which is a 720 gigabit per second Ethernet switch. And this is the driver which is using, and it says I found the board. So this is the board, the motherboard, and which is the AS5712, and it says I'm now connected to the PCI device, the Broadcom 56852, the Trident 2, and I have, it's ready to manage the ASIC. Now this example actually provides us with few options. So we can create firewall, remove firewall, show the layer 2 table of the switch, save configuration to the switch ASIC here, the ASIC cache, and also we can do some stuff. We have a diagnostic shell as well. So if I go to port the number 3, because I have the first laptop connected to the device, I'm expecting that should be enabled, but we don't see anything, right? The layer 2 of the switch doesn't show anything. So I'm guessing that that's the reason for those SFPs which we have inserted, and I know that that port is not showing up. So we will use the launching the diagnostic shell, port option number 9. Okay, so now as you can see we get to a shell called drive shell. We can do a help here. So these are all the commands which are directly talking to the switch ASIC. So we can use these commands to see what's going on the switch, on the ports. So we can get some kind of diagnostic information of the ports, for example. So I'm interested in to see what's the problem, what's going on with the ports. So the port mode and yeah, the port stat command will be able to help us. So I enter the port stat. So port stat command, it shows all the ports on the ASIC, which are all of these 10 gig ports. And as you can see, the port XE0 and XE1, which are port number 1 and 2, these two ports are both showing down. They are showing 10 gigabit per second and they are both showing down. Now to change the status of the ports or do the configuration of the port, I can just say port 1. So port 1, these are the information of the port 1. It says it's a 10 gigabit per second, XE0 and all stuff. So now I have to configure this port to become a 1 gigabit per second port. So I will say speed equal to 1000 and medium equal to, the medium is currently set as fiber, but we know it's a copper interface we have connected to, and copper. And we change the speed also, right? Yep. So after entering this command, if I enter port stat, let's see. Okay, so now port number 1 is showing up. Port number 1 is showing up, and I will do the same thing also on the port number 2. Port. So before doing that, let's quickly, before enabling the port 2, let's quickly go back here. So we finished almost what we were supposed to do here. So the management PC is still connected with the TTY USB with the console port here. I got this machine running connected to the port, to the bare metal switch, to the switch on the port 1. Now we will use the same machine. We will disconnect this port, this cable, and we will connect it to port 2 of the switch, and I will change the IP address here. So let me change the IP address of the machine now here. You can change it from just from here. And I can change the IP address from simply from here. So we will change that to 10.00.3, the same subnet mask. Okay, so the IP address is changed now. I can verify that from here if I do ifconfig. Yep, the IP address is not changed yet. I will do a restart of the networking service, and here so we change this IP. I need to change that cable now, so I will disconnect this cable and we'll connect this back here. And now let me change the configuration of this port. So I will say port number 2 speed equal to 1000 and medium equal to copper. Now since nothing is connected there right now, still it will show down, as you can see. Oh, now it's showing up, but actually there is nothing connected there right now. Now I will connect the ports, the cables, and we will set up a ping between these two. Okay, so I just swapped the cable, and you can see here we got the error, notification here that the management interface is disconnected now. The reason for that is now this PC, this connection is not there anymore, and this is the PC actually is connected to the port 2. So that's what has been done. Now on this machine, let's see what's the IP address. So the IP address is 10.0003, and I got the other machine connected to this switch with the IP address 10.00.1. Let's see if we can ping 10.00.1 from here, which is, you can see it is pinging, and we can reach to the other one. So this means that the switch is configured with the basic layer 2 switch function to be able to communicate between these two ports. Now if you go back to our switch silicon, let me quit from here, or if you want you can do again the port stat. It shows that both port number 1 and 2 are both up, ports running. And let me exit from here, quit. Yep. We are back again in this shell. So if I do this, number 3 show the layer 2 table, now we can see there are 2 MAC addresses here. So port 1 and port 2, there are 2 MAC addresses, and so I believe port number 2 should be the MAC address of this machine, which ends with E256. Let's have a look what is the MAC address of this machine. So our interface here, yeah, it is showing that the MAC address is E256, so it's the same. So this is how we manage to configure and program the switch silicon inside this bare metal switch using the OpenNSL. So OpenNSL, it's like a library and SDK from Broadcom, which you can use it for writing different applications on the switch itself. So you can create kind of agent softwares running on top of the Open Network Linux, and using the OpenNSL to communicate with the switch ASIC. So you can do the kind of traditional kind of switching, can create some interface to create VLANs, or do the modification of the switch tables. Also, there is another piece of software from Broadcom which is called OFDPA. You can use that agent instead of OpenNSL to directly communicate with the table. So OFDPA normally is used like an OpenFlow agent for the Broadcom switches, and you can use that to connect directly one of these bare metal switches with Broadcom chipset, which are if they are supported by the manufacturer and you got the drivers and the package, you can install the OFDPA and connect directly the switch to Open Daylight or any other OpenFlow SDN controller. So this was about our demo about Open Network Linux. It went all the details, and please, if you have any question, please write in the forum or contact me directly. Thank you very much.